So hello everyone. So we are going to solve the second example for the heat exchangers, and this one will be about the second method, which is Epsilon NTU method. Okay. And you can notice why it is Epsilon NTU method after we see the problem. So first we have that one shell, two passes, and we have a cold water at 18 degrees Celsius. So it is not stated if it is in tubes or in shells. So let's say that if it is in the tube part, and this one is the, let's say, cold one inlet, and this will be the outlet for cold outlet, and it is 18 degrees Celsius, which is the inlet for the cold part. And now comes the hot part, and for hot part the temperature inlet is 78 degrees Celsius. So this one is 78 degrees Celsius hot inlet, and this one will be the hot outlet. Okay, so the flow rates are given, and find the outlet temperatures when UA is here. So you notice here we are trying to find the outlet temperature, and for outlet temperatures we use this method. You can use this method, but here you have the logarithmic relation. It makes the problem complex, and this one is easiest one. So what will be the steps? Firstly, to find the outlet temperatures, I need to know the Q dot, because Q dot is equal to m dot Cp delta T. Okay, from delta T I can find the temperature difference, but I don't know the Q dot, but I know that it is equal to epsilon into Q dot max, and I know that epsilon is function of NTU and lowercase c, and lowercase c is c minimum by c maximum, and NTU is UA by C minimum. I know this part, I know this one, therefore epsilon is found. And now comes the Q dot max. It will be minimum C into delta T max. Okay, so now I can find these two here, then the Q dot is okay, and then the temperature values. So this one will be chart or table or formula. You can use whatever you have in your hand. Let's solve the problem now. Firstly, let's write the values in Excel. And let's solve this problem in Excel. Okay, let's write the values in Excel. So we have the T cold inlet, which is 18, T hot inlet, which is 78, and the mass flow rate of hot, which is 12,000. So it is 12,000 divided by 300, 3,600 to make it SI unit. M dot for the cold is 7,000, so it will be 7,000 divided by 3,600 to make it SI unit again, and the UA is given as 14,000, and the CP hot is 4192, and the CP cold is 4175, and from here I can find the C hot, which will be equal to CP hot into M dot hot. I can find the C cold, which will be equal to CP cold into M dot cold, and the minimum of these three values will be the minimum of the values here. I will need also the maximum value here, therefore I will find the maximum here. Firstly, the C value, therefore I need to find the maximum of it. Maximum will be maximum these two values, and the C value will be the ratio of these two. And now comes the NTU. NTU will be UA divided by the minimum of this. Now I can go to chart to find the values here. So I go to chart, so the tables, chart graphs. So I have the figure here. So I'm going to look for one shell and two tube passes. So one shell, two tube passes will have one shell and two tube passes. This is the chart, and the value is, let's go back to here, C is 0.58 and NTU is 1.72, and first the NTU value it is 1.5, 1.72, it is somewhere in the between, and the next value is 0.68, and you will be around here. So if you go back in that chart, approximately the value will be 65%. Okay, less than 65, 62, 63. Okay, or if you want the exact value for this one, you can go back to formula here. Shell and the tube, you have one shell and the number of tube passes are here, and we have two tube passes, and then for this one you can use the formula here and find the exact value of the effectiveness. But we'll use approximate value here, but if you want you can do it. So it will be, as you have said, it will be 0.62. The approximate value will be 0.62. Let's write it. Effectiveness epsilon will be epsilon will be 0.62, and now comes the maximum of Q dot. Maximum of Q dot will be minimum of C value into maximum temperature difference. Maximum temperature difference is the difference between inlet temperatures, because outlet temperatures are dropping. Okay, these are the values that you can get in heat exchanger. Okay. So you have the maximum, and then I know the epsilon, I know the Q dot max, I can find the Q. So it will be this one multiplied with the epsilon value, and then I can find the outlet temperatures. If I go back to here, I know the Q value, Q, if I divide by the Q value m dot Cp, and so delta T water inlet, and I will get T water outlet. This one is for the cold part, and for hot part temperature drops, therefore it will be T hot inlet minus Q dot m dot Cp, and it will be T hot outlet. Okay, and this will be the equations, and I will write those equations. T water outlet, it will be equal to inlet water temperature. Let me write it. T cold outlet, it will be inlet cold temperature plus Q divided by m dot Cp of the cold. M dot Cp of the cold is exactly the same as C of the cold. So 52, 55, and then T of hot outlet, it will be inlet minus the value here divided by the C of hot. Okay, and 56 degrees. Okay, these are the temperature values for the hot and the cold outlet.